Hi everybody, my name is Ece Eroglu. I'm a third-year student in the Bozok Medical Faculty of Turkey, and I want to talk to you about a topic that is on the agenda these days. So my topic is vaccines that provide a major benefit to us when it comes to COVID-19. And have you considered how those vaccines are created and how they affect that virus? So this presentation will be a very short summary of the COVID-19 vaccines. Yes, I'll start with my presentation plan. First, we will talk about how the virus affects our bodies. Then, we will look at the types of COVID-19 vaccines and the conclusion part. So, if we are to develop a vaccine, we must know who the enemy is. The COVID-19 virus is a member of the coronavirus family, and this virus is an enveloped virus with an RNA genome. So, this virus penetrates our cells through a protein called spike. The spike protein binds to angiotensin-converting enzyme 2, which is ACE2 receptors, and when the link between spike and ACE2 is formed, symptoms like cough, fever, and weakness occur in our body. Yes, this is now we generally know our enemy. We can use various structures of the virus to develop a vaccine against it. Let's begin with inactivated vaccines. These vaccines are produced by first growing the pathogen on a substrate. In this type of vaccine, it is injected in an inactivated form to induce immune system factors. Let's take an example of these vaccines. So, Sinovac is the most famous inactivated vaccine. Another way is to weaken the live virus and inject it into the organism. So what is the meaning of weakening the virus? The COVID-19 virus induces cytokine storms by releasing too many cytokines into our bodies. However, the attenuated vaccine efficiently stimulates the response of T and B cells. I should also point that this method may carry risks due to problems such as virus recombination or transformation into a virulent genotypic strain. An example of this vaccine is CoBioTech. Here's the question: which is one of the most important components of a virus? Yes, answer is nucleic acids, which are used for replication, are extremely important to the virus. Therefore, there are also nucleic acid-based vaccines developed. The most well-known of these vaccines are mRNA vaccines. So how are these vaccines different from others? In the mRNA vaccine approach, your body produces the protein belonging to the virus in a way that it can tolerate and defend against it. To give an example of these vaccines, Pfizer and Moderna vaccines are most known mRNA vaccine. Are there any other vaccines? Is that all? Of course not. I just summarized some of the major known vaccines. Now let's look at the conclusion part. I should point that it appears that the new vaccines developed may also cover the problems associated with new mutations. So these are my references. Thank you for your attention and stay with science.